Okay, first of all, if you're watching this, thank you. I appreciate it. Lets me know that I didn't waste my time coming in here this morning because it's 5:26. But Lily's sleeping, so that's okay. And my wife's at home. I didn't leave my kids at home. Okay, so we talked yesterday about how we can factor sum and difference of cubes problems, and the reason we want to be able to factor that is so that we can simplify this, because plugging this number in simply isn't going to work. If I put a 4 here and I put a 4 here, I'm going to get 0 on the top, I'm going to get 0 on the bottom if you do that calculation. So that means I know I can simplify this. We talked about how to do this problem where when we're simplifying or when we're factoring the difference of cubes, it helps if we write this as what's being cubed. 64 is 4 cubed. Okay, so now my difference of cubes looks like this. We've kind of switched those around, which is actually going to play a part in this. You want to pay attention to the end on this one. Okay, when I switch it like this, that's going to make a difference. On the bottom, okay, you should know exactly what to do with the bottom. Okay, we've got the difference of squares down here, which we can factor into conjugates. Right, the square root of x and the square root of 16 go here and here, one with a plus, one with a minus. We've done that 100 times at this point. For the difference of cubes, I've got that written right here. So the 4 is taking place of a right now. So I'm going to put a 4 everywhere I see an a in this model. Okay. And the x is taking the place of the b. I'm going to put an x everywhere I see a b in this model. So we get that. And when you look at that, I think that was pretty straightforward on how that gets factored. Now the reason, if you recall, the reason we're doing this is because when we plugged in 4, we got 0 over 0, which meant this could be simplified. And that meant in the previous problems that we had done with problems like this that we had common terms that we could cancel out. Okay. When you look at this problem, where we're at right now, nothing looks exactly the same, right? Like this looks very similar to this, but it's not that. And there's a little bit of a trick a little bit of a twist that we have to apply to this problem. Okay, so obviously the x plus 4, we're not going to see that up here. This is not the same as this is not the same as this, but these are very similar. Okay, and the one trick that I'll show you today that you can do with this to make this the same as that is factor out a negative. If I take -1 and I factor it away from just this term, that means I'm dividing this by -1 and I'm dividing this by -1. If I divide each of these by -1 and I pull that out, they flip their sign. So the positive 4 becomes a -4 and the negative x becomes a positive x. So I end up with that term which is in the bottom. I wanted to have that say x minus 4. I don't get to switch subtraction, right? 5 minus 2 is 3. 2 minus 5 is -3. It's not the same thing, right? It's actually the opposite. So if I want to switch this around, I can switch it around if I make it the opposite, and that's why that negative's here now. Okay, so we have 16 plus 4x plus x squared here. Now when we look at this, problem, I can cancel these. But what's going to remain when these cancel is this -1 is still going to be up there. So now I'm doing the limit as x approaches 4 of a -1 times 16 plus 4x plus x squared over x plus 4. Okay, now when I plug this number in, I should get something that isn't 0 over 0. So I plug the 4 in. On the bottom, I plug in the 4. Okay, up top 16, this is 16, and this is 16, that's 48. So I have -1 times 48. On the bottom, I get 8. And when you calculate this, you have -48 over 8, which is -6. So the limit as x approaches 4 is -6. I got there by factoring this, but I had to twist this one around and make it negative so that I could cancel it with that. You're going to see that one or two more times before we get to the chapter test, okay?